I just don't know as much about it.
What do you think if someone's getting into like from zero right now, because I talk about like a lot of things. I don't so much talk about, especially the pipeline to like software engineering and web dev and stuff like that. But in terms of the pipeline to like what you did to not have a PhD and to essentially self-train with a boot camp assisted to be a high level machine learning engineer. Right now, today, if someone was at zero, what advice would you give them?
What I would basically do is, if you want to go from zero to useful, like in a short period of time, I'm a strong believer in like the hands-on reverse engineer approach. Basically, like I would start with Python. The reason why I would start with Python specifically, I would start with typed Python. I would like basically, because what I think people need to get is an intuition of computer science principles, because those principles are why languages are what they are. And you were kind of talking about this last night with JavaScript a little bit. I think JavaScript should be the second or third language you use because it's so abstracted and it's 100%. So cockamamie how like the logic works, where if you've used Python, if you've flirted with C++ a little bit, if you've maybe looked at some Java, then look at JavaScript, it's going to make sense why they cut the corners the way they did to implement a faster web glue like language, which makes perfect sense. But if you want to like kind of go like, how could I go from zero to hero, learn Python as a backend, learn database stuff, like in the sense of like, how do you set up a SQL server and then build an API to call like Reddit and store that information in that database? Like, how would you do it? That's an important skill set, because a lot of companies actually just want you to build like fast like middleware, essentially. That's what your first job will most likely be like, unless you're trying to be an analyst of some sort, or as I see RC Ian here, if you're trying to be like a cybersecurity professional, that's a different game. You need to learn networking. You need to learn like you need to understand protocols more if you want to go the cybersecurity route, so that you can break into things and like that's how I kind of see it. But if you wanted to kind of go where the job market is where they're really trying to bring people in right now, I would start learning how to build apps like with like a Flask front end or a React front end. So anything that gets you touching JavaScript and Python, like go that route, like chase those things and try to create apps that are what I call intelligent apps or dashboard apps. Those are a little bit more important things that get you like, so if you have 0 projects and you want only 1 project to get you a job, if you could build a real-time streaming front end that's doing analytics on the stream and that dashboard's in real time, then they would be like, cool, we got it.
I love that.
Because that forces you to build a database, forces you to think about like message queues and like Kafka and stuff like that, forces you to think about data visualization, forces you to think about how you want to aggregate, display that data, and then forces you to build a like intuitive UI. And if you can do all those things,
is business case. It's like so used in the world. So another thing, with web dev needing to learn machine learning, it's not even as much, don't look at so much as like needing to learn machine learning, is that every engineer, in my opinion, should be gaining it's fairly intensive knowledge around data and statistics and modeling. And machine learning is downstream from that. So it's not even that machine learning is the thing you learn as much as you learn about data. And data viz is a part of that. And like just from Matplotlib to D3, like data viz is a huge part of data. And the cool thing about if you learn web dev and data is you can build, like Matt's sort of saying, is you can build like your front ends to all the data work that you do, and you can actually do something and show it in a portfolio sense or to a user super easy. And right now, data is the game when it comes to sheer value, because we're in a bring Matt to more streams. This dude has enriching. No, Matt. It's so funny. I was like, I have to get Matt on the stream because like people need to know about Matt. Like you know, like a lot and you have a very intuitive way of thinking. But yeah, so like, yeah. So I know it's hard. It's weird getting compliments. I get it, but it's like,
I appreciate it.
but yeah, I think like data is like such an important discipline to have right now.
Yeah.
But and also being able to build stuff like so like when you're with like building a portfolio right now, let's say they do actually have like 6 months to build a portfolio to get like a machine learning job. Do you think that that's something they should even do? Or like, if so, like what are some other projects you think would be a good idea?
Power BI is great for business analyst and data analytics. Tableau is another good one for that. I just saw that pop up. Those are great for data viz. That's a Microsoft product that basically consumes your data and allows you to drag and drop how you want it to be displayed. That's a super powerful tool. The only thing with using Tableau and Power BI is you're probably going to be more so in a role that is presentation oriented, business analyst, in the sense that you are maybe not building the pipelines to the data, but you're the consumer of the data, and someone else in your company's built you the pipeline, and you're basically controlling the aggregate and building the analytics, because the tools like Power BI and Tableau are really powerful in giving you an intuition of like how to match a table together, or how to combine data points to derive some insight. But going to your question really quick, you said specifically if they're looking to get a machine learning role and they have 6 months to build a portfolio.
Yeah.
Okay, so what I would do is there's 3 basic things that I would do right off the bat. One is implement a few algorithms from scratch. Go look at how to build a principal component analysis module so that you can have high dimensional data and bring it down to low dimensional data. Build a support vector machine from scratch. These are all things you can do in a day. There's tutorials all over the place. You just want to build working modules of it, so that and maybe comment it pretty well, and write a README that shows that you understand the math behind it to some degree. Yeah, READMEs are huge. So that would be one thing. Show that you understand how to implement the algorithms. It doesn't mean that you need to be able to write the formal math out. That doesn't matter. You need to know the intuition, and you need to know how to implement that intuition. That's what they want to see there.
Right.
Then what you want to do is show that you can gather a data set. So maybe use a baseline data set at first, but eventually what you want to be able to do is scrape the web and build a data set. That is
what's huge. Up. Look at my streams.
Unless there's only one other alternative to that. If you happen to have mechanical devices that have sensors that read out metrics, and you can aggregate metrics from your mechanical device, that can be big too. This could also be if you ever track like Fitbit, or you use some type of app to track something of you, and you can pull down that data set. That's unique, and you can use that as well. Financial data is also good if you want to like analyze your own financial patterns, things like that. But if we're just making a portfolio here, it would be really impressive to be able to say, can I categorize a set of YouTube videos? What would I do? So, you want to pull down some of the metadata. This shows that you have some insight into, connecting and pulling things from the web. But also what you want to, so once you have this data set, right, without going into all the details of the YouTube thing, but let's say you have this data set, what you want to be able to do is show that you can train multiple models on that data set, and that you can basically compare the models. That's big. So like one of the things you want to do is you have a benchline, you have a data set, you want to create a benchmark model. So that's something that's like, just like, where do we start? What's the cold turkey? How's that? And then show that you can make decisions to those parameters that improve the model's performance. So, so first you want to show that you can implement the intuition by writing out like a PCA module, support vector machine, or whatever. Like these things sound crazy, but they're really not. Linear regression, logistic regression, can you do it? Then you want to show that you can start from a shitty model and make it a good model with custom data. that is huge if you can show that, because it shows that you understand the intuitions of model drift. It shows you understand the intuitions of how the data should affect the model, and that you can validate that hypothesis. That is big. And then the third one is what I already said: build some type of real-time analytic dashboard. If you want to do that in 6 months, you can knock out those first 2 projects in a week. Honestly, just go look at tutorials. Go look at O'Reilly.
Take notes, people. This is really good information.
Yeah, go to Kaggle, go to Hugging Face. Here's a beautiful thing about Hugging Face. Hugging Face literally has to do a lot of this stuff to justify the model card in the first place. So go and look at what they did to justify why you should use that model, and then create your own little variation of that explanation somewhere.
Interesting. Wow, that's and so like what you're saying, if like someone presents you this portfolio, let's say you have to hire a junior for yourself and your job, like these are things that would impress you, essentially.
Yeah, exactly. And if they had no portfolio, because let's just say like they didn't, because to be honest, I'll say this, ever since I've been like hardcore full time over the past like 3 or 4 years, my GitHub contributions, my personal GitHub contributions have kind of waned, but my internal company GitHub contributions, crazy, right? So I know that if I were to leave this company and go to another company, what they would see is like 3 years of like kind of nothing, and then like a little explosion of activity on my GitHub. And they might say, what were you doing? And I'd be like, well, I signed an NDA. I can't talk about it. But but so in that scenario, maybe you don't always have something to show portfolio wise. So if in that scenario, what I would do to interview someone is I would start asking them intuitions again, because I want those 3 same things. I want to know that they understand that if I'm talking about why would a support vector machine work in this nonlinear 2-dimensional data?
Yeah.
And I want them to tell me, because the relations can actually be parsed up in a higher dimensional space. So you use the support vector machine to project it into a higher dimensional space so the calculations can happen there, and then it gets brought down to a low dimensional space. That's the point of the support vector machine. And I might say, okay, well, why is that different than principal component analysis? And if you can answer that, why is a singular value decomposition better than PCA? And if they can answer those questions, then I know they know the intuitions, and that's all that's important to me, because you can just pull down NumPy, scikit-learn, and implement the algorithm in like 1 line of code. I don't care about, do you know the symbolic math? Then I'm going to talk to them about a real scenario. I'm going to say, hey man, if you're running a music venue, and you've got bands to take care of, you've got the hospitality bill, you've got ticket count, you've got sales you want to take care of. How would you use those features to predict the outcome of the show? What would be the intuition on that? And get them thinking through those data science questions. And then I would just basically ask them, how would you use, and I would hopefully, working at whatever company I am, have a data dashboard tool. And I would say, without you knowing anything about this, just look at these visuals and tell me, basically Rorschach test this for me. What do you see? And if they could say, well, there's a spike here and that spike's correlating with the spike here, maybe these 2 data, features have something in common. I'd say, okay, that's what I'm talking about. I just want to see some common sense about this.
So I really like that. And that's really good for anyone watching that's like currently in the process of trying to upgrade your tech career, become a better engineer, because I've seen this with senior engineers, people that are often in interviewing people, and they're the ones you really need to win over, because they get a lot of respect once people are vetting you at the table. It's less so. That's why people often don't care about nitty gritty of programming languages. They care about whether you can see the through line of the concepts. Like you said, okay, why would you need PCA over this other dimension reductionality method? It's like, and then if that, there's another case, and I think obviously I'm not a machine learning professional, so I wouldn't do well in that. But like,
no, you would. You and I have actually had these conversations. Just we didn't use like what.
I'm trying to be humble for once, Matt. Let me be humble.
I just want to tie it into what both RCA and Luigi said over here. Is like lingo is actually important.
Yeah,
in
it is. It
in
is.
this in the terms of the industry, but lingo is not important in terms of the ideas. And
Yeah,
that's what
yeah,
I mean. Is like you and I have totally had these conversations without ever once saying PCA or
right,
SVM or LSTM because we're just talking about it, right?
right. And when people are vetting you for jobs, they're typically breaking down concepts that they have to deal with every single day and trying to get you to like think on their level on it.
Mm-hmm.
So yeah, the lingo will matter to some. Well, depending on the job, it'll matter a
Right.
lot actually because they don't want you to not. If you're senior, mid-level to senior, they're not going to want you. They're going to want you to know lingo.
Yeah.
But like seeing the how you think in terms of problem solving is like the main thing they're vetting. They're trying to find good problem solvers, and like so
Exactly.
that's really that's cool that you broke that down. Yeah, like is there anything like that you think next steps of like if someone wants to get specificity and become like a higher level machine learning engineer in the next
Mm-hmm.
5 years or even like 2 years, like what they should focus on?
Uh, Yeah, I do actually have an answer to that, but I will say this to RCE. Yeah, I mean that would be like an awesome side hustle. The SQL data analyst, that would
Oh
be
yeah,
cool. That's available actually. I think it's you have to go through humble methods initially, so like a Fiverr approach, some type of like helping people type approach would I think would you have to build that up to some degree. But like I do think there is actually a world where there is like in the same way in like maybe 2010 2011 I made money off copywriting basically. This was not a main job, this was just a total side hustle. What I would do is I signed up for these like text agencies and they would send a brief and basically like hundreds of us would just send it in and they'd have some algorithm that would like pick out the right one and whatever. Data analysis like that will be available soon. There will be companies who just want to outsource analytics very quickly. And if you want to like build that up, I would start building a GitHub that shows that you can write cool queries, mock up a database server, pull out tables, and show that analyst stuff like that. So that world's out there.
Interesting.
But for the ML thing, if you, let's say, I'll just tell you what I did. So what I did was I got good at implementing my intuition and understanding the general narrative of intuition in the algorithms, meaning like, how did we get from linear regression to a transformer? Like what was the kind of story and motivation from like being able to just predict a number, like after a number to full on like super fancy autocomplete, right? Like, and I kind of understood it in a way that I could talk to it, but I wasn't able to, formally write down what they all really meant. Like what was the symbols that, mathematically proved this thing. I wasn't quite there yet. But I could take a business problem and I could understand the category that would best solve the problem. So like, is this a classification problem? Is this a regression? Like we need to predict something, or is it like, we just need to analyze and break apart segments of the data and cluster it? Like I understood those basic algorithmic principles and then understood how to translate the business problem to using that thing.
Yeah.
And because we live in a world of packages, I was able to pull down a package that we know is stable and reliable, so that basically I was just like finessing and massaging the data because I knew the algorithm was like solid already. Then what I started doing was being like, okay, can I build without like using any package the same reliable structure? And then I was tasking myself with that. And you start with like maybe NumPy, and so maybe you're relying on like operators, but you're still building out the whole algorithm. And then once you start doing that, you think, well, how can I optimize it? Start thinking like, okay, so like if their algorithm is the same thing as mine, but it happens literally seconds faster than mine, what's slow about like my thing? And that actually got me really involved with understanding like what's going on under the hood with Python, what the garbage collectors are doing, like what problem that's solving from C++, and how it allows me to not have to think about memory allocation or anything like that. So I started to understand like what makes the algorithms work in an optimized way, because that's going to tell you about scale later on in life. Like you're going to start to think, complexity is really based on how is this optimized or not.
just to interject real quick,
Mm-hmm.
when to talk about understanding memory really early on, this shit's making me 10x. It'll make you 20x. So like, this is actually a really important conversation, because at this point, people don't understand so much when they're trying to get a job, and they're like, how do I answer these questions about scale and all these things when I haven't been in industry? One of the best ways you can get competent at understanding the scale and getting good at being almost sounding like you're a senior engineer in a interview is by dealing with memory early on in the language. So understanding, like you just said, how the garbage collector works, if you're using a dynamic programming language or using Java, something like this, like study the Java garbage collector, because that's the most inventive one, or at least the one that sort of like brought about that concept into the mainstream. Understand, like, mess around with C. I think everyone should mess around with C, because you might not be using it professionally, but you should absolutely understand pointers 100%.
So to this and to read, you don't have to be able to write C. You have to understand why Python, like, what does Python solve?
Yeah, that's what I mean.
Yeah, exactly. So it's like, you don't need to go and become like a master at C++. You just need to understand what C++, like, why is C++ object oriented, and what did that solve from the functional version of C? Like, what did that jump do? And you're going to learn it has to do with state and has to do with memory. And you're going to learn that. And then you're going to realize Python is an evolution of that, where it handles all the state and memory for you, so you can just script objects. And then, like, because that's basically what Python is. It's a scripting, it's an object scripting language where memory is like taken care of, and you don't have to worry about types if you don't want to, which gives you crazy freedom. It gives you crazy freedom. But I want to continue on with the ML thing really quick, because if you want to go from an applied ML engineer and you want to become more of like an ML scientist or an ML like researcher, where your main job is not to create applied pipelines that give you insights, but you have this job where you're doing a little bit more research and development. And so, just so you guys have a little understanding, I spend about 2 quarters of each year in R&D, and then I do the next 2 quarters in basically the implementation of the R&D that I worked on, and that's kind of how my year works essentially. Writing your own collectors, that would be. Yeah, you should. You can actually do that. You can find a tutorial and follow it and do it pretty well.
Yeah, that's a CS. There's typically CS courses do stuff like that.
And like compilers and understanding how like all that's working.
Read the Dragon book.
Dragon book is huge, dude. That one's very good. And then data structures and algorithms, obviously, we all love. But anyway, so if you want to get into more of like a place where you're proposing like business solutions and creating like novel implementations of algorithms, the next thing you do need to do is you actually do need to go and learn the math. That's the next step, is like you need to have a strong understanding of like why is like Bayesian called naive? Like, what does that mean when we say like naive Bayesian methods, and what type of probability structure is working there, and how do you implement that in symbolic language? Because what's going to happen when you're in the research level is you're actually not going to be coding that much. You're going to code to basically, in some non-optimized way, prove that your math works. And then once that works, you'll either be the person that optimizes it, or you'll hand it to a team who writes it in such a way that it's hyper optimized. But on the research level, if you want to be at that space, you really need to understand why matrix multiplication is the core of machine learning, like how vector representations and like basically like linear algebra and linear control theory, actually, how matrices and vectors represent state, and how mathematical operations are essentially manipulations of that state. If you can come to that conclusion and write out a symbolic form to basically express that idea, then people are going to give you a lot of credibility, because a lot of people can't do that. And if you can look at an algorithm and explain in detail exactly how the flow is occurring in the algorithm. And I'm talking about with like math symbols. If you can explain that and then also relate that to like how it looks in Python, and you can say, here's the language, here's the idea, here's the implementation. When you can very smoothly talk through all of that and confidently, then like, yeah, you're in R&D land for sure. And you're going to be given a lot of freedoms. But you don't need to do that if you don't want to. If you just want to get like a 6-figure gig and be like an applied machine learning engineer, totally doable. And you can do the first couple of things we said, and you don't have to give yourself the headache of attempting to be like a researcher. But that stuff will never hurt you. So if you want to, like, I always advocate, keep learning, keep taking it. Like, you are in a constant competition in this industry, and
with
literally
dudes like Matt. You're competing with dudes like, understand you're competing with dudes like Matt here.
Yeah, so if you want to beat me, you just have to like read as much or more than me. And I'm not saying I necessarily read a lot. It's how I retain the information and how I communicate it and implement it.
Right.
So if you can speak it and you can think it and you can implement it, then you have the power. But the only way to keep up with that is continuously reading basically white papers and GitHub repos. And also, don't believe the magic. If a group comes out of nowhere and is just like, yo, I just solved this cool thing, it's very cool, like blah, 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 this, that, you need to be able to know how to look at their data set and know if they tricked you somehow in that. Is there some duplication in that data set? Is there some bias in that data set that sways the statistics and things like that? And then how does that affect the modeling? Actually, you know what? I think that would be a really good way. Go to Kaggle competitions and look at the people who lost and see if you can understand why they lost and why the people who won.
Ooh,
what's the difference
like
about the models and the data they use? How did they process the data differently? That would be maybe a good insight.
Kind of like a game theory approach.
Yeah, exactly.
Yeah, no, like that's really intelligent. And also when it comes because this past year I've been like spewing like long texts at Matt as I've been learning machine learning, and partly the things that, because he sent me tons of valuable, because literally what he's saying is partly why I can do these. Like, I mean, I knew Python for like a decade and all that, but like part of the reason why I can do a lot of machine learning stuff is because of a lot of like Matt's help this past year. And I'm telling you, the resources around understanding dot product, understanding where cosine comes into play with vectors in a scalar space, understanding what vectors are, these things blew my mind. And also really look into the math around backpropagation. Yeah, if you're because that's the thing that actually
that is learning.
Learning about gradient descent really is the thing that got it so I could from scratch write some models here. So that's that's me sort of like trying to translate like a good entry point and understand the math concepts. Why don't boot camps cover this level of detail? Yeah, I know, right?
They used to.
Where do you find these white papers? I literally, it's probably a better question for you, but I just like Google. I look at GitHub and I look at Hacker News like every day. And I just like, I'm just constantly Google searching. I'll find white papers looking at problems that I'm dealing with. Like I found this really interesting, I've been messing around with HTML language models recently. And I found this like DOM LLM white paper and like, but Matt, yeah, that's probably a better question for you.
Well, I mean, there's the main repository that you could go to, which is archive.org, but it's spelled a little differently. I'm waiting for the Dragon Book link to load, and I'm going to send that in because I see someone wants to know about it.
So the Dragon Book's just it's like the best book about learning about compilers.
Exactly, it breaks it down. I'm just going to put a link in here, but actually, if you want to you should put in arg. It's like ariv.org. I think I'll confirm that in a second, but here's the Dragon Book for whoever is interested in that. That's coming in. That's the direct PDF. You should just be able to download it. I believe this is the one in English. Yeah, this is in English. So the other website that is like basically where all of these white papers live is archive.org, but I need to make sure I'm going to the right one. Nope.
Yeah, everything's on the site.
Yeah, but basically what happens is the repository is where everyone posts their paper to make it legitimate, and then they go and do their own marketing campaigns by wrapping it in a GitHub, putting it on LinkedIn, whatever they need to do to draw attention to it. But you can just look at archive.org and it will be there. And I believe this is it. Yeah, that's how you spell it. This has like everything, man, but it's not even just machine learning. Like archive.org.
Oh, you can't see the link?
Oh, really?
Which, RX.
Yeah.
Yeah, I mean, that's every single white paper I've seen has been on there.
Yeah, but it's not just machine learning. This is like all white papers. So you want to look at I'm just looking at the top things on the front page. First, it's physics. All the white papers on astrophysics to like general relativity, quantum physics, to high energy physics, go into mathematics, go into computer science, quantitative biology, quantitative finance, statistics. So this is just a resource for like good documents being submitted by basically well-educated people who are solving some niche problem and they're writing a paper about it. I would say probably in the last 4 or 5 years, archive.org has blown up with machine learning papers. It feels like we one like every 20 minutes. So don't feel overwhelmed. That's the biggest thing, though, going into the machine learning field is don't feel overwhelmed. Understand that at the core principle of the science, it's a very simple idea. And that the idea is that trial and error is brute force knowledge. And machine learning is basically you're brute forcing knowledge. You're literally trying something at like a million times faster, not a million times faster, but you're doing something a million times in the time it would take you to maybe think about doing it once. So, and it's basically distilling that through trial and error. So it literally, like machine learning is literally this. I'm the model. This is the data set. And I go, that's a cat. And there's a score that says, you're like 50 points off. I take that 50 points off and I go, all right, I'm going to adjust everything that made me think this was a cat by 50 points in a direction. Yeah. And then I'm going to say, okay, now what is this? And I go, maybe it's a car. And then it goes, nope, now you're 70 points off. I'm like, shit, I went in the wrong direction. So let me go back and adjust everything by 70 points in another direction. And then I go, it's a phone. It goes, you got it right. And I go, okay, cool. That's the association. This is a phone. New thing. Is that a cat? No, you're 80 points off. Okay. And so it's just that's all you're doing it, but you're just doing it in a different.
Oh, dude, I don't think your links are showing up.
Oh,
hold on.
Really?
Let me just write and see if mine arxiv.org. Let's see if
that one popped up. I can see that.
Yeah,
but I can see it in this chat. Maybe it's not on YouTube. It's chat.
How do I just?
Whoa! It popped up.
Oh, nice! Look at that.
How did you do that? Yeah. That's cool. Yeah. Go and highlight all those.
I actually don't think anyone can see that. Oh, they can see it on the stream. Look at that.
That's great. Yes, RCE. What the Not Hot Dog app is a great example of that. Silicon Valley, to be honest, while it is a joke of a show, like I mean, it's literally a comedy show. They're not wrong. Like what they talk about in that show is like pretty spot on. Like what was happening from like 2008 to like 2019. Like that's literally what was going on in the industry. So you're not wrong. Pay attention to the lingo as the seasons change too. But there's another thing. Data Science Handbook, great book. I believe that's a Manning publication, if I remember that one correctly. That is anything that's a Manning publication or an O'Reilly publication. Solid material. Solid. PACT is another one too. PAKT.
Oh yeah, dude. O'Reilly Python book, the reference book that was amazing. Like this big. Yeah. When I was like 14, I remember I was reading that like all day, and I remember I thought the way people made GUIs was with TK Inter, and I was using TK Enter. No one has ever used that for anything ever.
I know one guy who literally uses it at his job.
No.
He works for a chemistry lab, and he builds basically analytic dashboards for their chemistry stuff. But it's they're a 100% Python ecosystem, so they're not.
Wow.
They're not optimized.
That's funny.
But he builds TK Enter dashboards for their chemical readouts.
It's this like standard library Python GUI that's just so bad.
So clunky. Actually thinking about that, even though you would probably benefit more from PyTorch nowadays as your go-to library, there is an O'Reilly book called HandsOn Learning, TensorFlow, and Scikit-learn. Priceless. The book will give you data sets. It'll give you code implementations. The great things about Manning, O'Reilly, and Pact is every book usually comes with the GitHub repo.
Okay, I think I found the Amazon.
Yeah, it has like a little salamander or something.
Yeah. So this is like a good book.
Oh yeah. That's like one of the early ways to get into things. Yep. Yeah. Machine learning, TensorFlow. That's it.
That's great.
But the key phrases, and I'll let you talk for a little bit. I feel like I've been going for a second. But
dude, this is you. This is your game.
This if you want to just learn something, this is how you should search for it. Hands-on, and then the thing. I'm not kidding.
So true.
Like, hands-on neural nets. Hands-on implementation, PyTorch. Hands-on large language model, hands-on data science, hands-on. The thing is, there might not literally be a book called hands-on, but everything that returns to that will be legit. It will point you in the direction of some type of textbook that focuses on implementation, and that's just the route you're going to want to go until you got it under your belt, and then you can look under the hood and dive deeper.
So what do you think about the Go, as Reed's saying here, the Go Postgres stack?
Mm-hmm. Okay, so also in learning solidarity for blockchain is worth it. Should focus on the web dev and AI nowadays. I mean, blockchain has a place. It's more niche, and you're gonna if you learn blockchain, you're gonna kind of end up in the financial sector because that's where that technology is going.
Definitely.
That's a surveillance technology. So that's going into the financial. So if you want to work for banks, learn blockchain. I don't really believe in the crypto space. It is real. Like crypto is real. There's no doubt about it.
Yeah.
But it's just a really easily scammed. And I think the trajectory for crypto is that like the centralized banks will become the whales, and they will basically control monetary. Like we won't. Okay, so when the centralized banks own crypto, we won't need to fake a recession. They're literally just gonna convert it to USD, and we'll all lose a bunch of money for a little bit. And then when they're happy with us, they'll pump us back up. But going to Go and Postgres. Go is a great language. If you're dealing with networking, Go is, no pun intended, the way to go.
It is.
No doubt. Like, if you want to do anything networking wise, like you should kind of have Go, because it is the most performant concurrency language. So you can handle all this type of messaging. And it's really simple. Go is actually a pretty straightforward language. It's not really that complicated. I would learn Python first, though, because Go takes the principles of Python and basically gives you the power of C++, which Python does too, but Go does it in a different way. But Postgres and Go, no problem with that. Like if you're already kind of learning that stuff, it's good. It's a strong thing to have. Python is just something that there's two types of Python users. There's like a Pythonista who's like kind of like Python all day, every day, fuck everything else. Stay away from those people. No good. You don't want to be around those people. You want to be around people who like kind of like Python second nature, babies can do it. Like you want those people who can be honest about what a scripting language is, but still write awesome programs with it. Those are the people you want to be around, because they're going to encourage you to learn Go, to learn Postgres on another level. But you just kind of like Python and JavaScript are kind of like entry to the club, I feel like. And then like once you have that, under your belt, like you'll naturally figure out what languages will assist you in whatever types of projects you're working on. No, I don't think you should read Dragon Book in the whole.
I was going to
I would
address
say
that.
read sections.
Yeah,
but
real quick.
You take it.
Yeah, with that and with the should your focus be on web dev or AI, I actually think those two questions are kind of in the same realm. Just go to where you're curious, because it may be that you just read the Dragon Book in a whole because you want to.
Yeah.
Because really the people, like whether or not your focus is in Go or blockchain or web dev or AI, if you're really curious, you'll get 10x. The
curiosity is what makes you a good programmer, by the way.
Yeah, exactly. Because curiosity is the fundamental of problem solving. So it's like you can't solve any problem without curiosity, really. Or you can memorize. But that's only going to get you so far.
Yeah.
But yeah, so like but I mean, you can. I I say if you can read books like that to the entirety and get, that's a huge book, by the way.
Yeah.
But yeah, I think and so what do you think about though, like if we don't just go the kind of hokey path of curiosity I went, if there is a hard path of blockchain versus web dev versus AI and you have to give the answer right now for somebody who like wants to have a fruitful career, what do you think?
I mean, we did kind of, I wouldn't go the blockchain, what we call Web3 route. I wouldn't do that. I don't think inventing coins and trying to build up like monetary currency policies, smart contracts, like, sniffing ether, whatever they're doing over there. Like I wouldn't do it because I think it's a waste of time. I think if you're already like highly advanced engineer and you have like a VC who's trying to rip a bunch of people off, then like, yeah, go the crypto route. You'll be very valuable to that person. But to start in that world, like the stuff is so abstract already that I don't know. I just think the crypto thing is a really hard place to start. You're going to be like more worried about like fast proxies and tracing things, and I don't know. That's what it will be at the end of the day. What you should do is you need to understand that you at core have to be a web dev. You have to understand how the internet works. You have to understand how to pull data from a website, how to automate a website. You don't necessarily need to know how to build the most efficient UX, like client approved market data, like thing, but you need to understand the fundamentals of data science and the fundamentals of web dev. That's just what you need to do at this point. And then if you can understand the fundamentals, and like I said, the types of projects that Jared and I have talked about, they will teach you all these things. Like building a real-time dashboard literally teaches you web dev and data science simultaneously. So if you have those fundamentals, once you get into a job, the job will kind of direct you a little bit. Like no one wants an engineer to come in and build everything for the company unless you're like working with a startup. But like if you're just kind of joining a team, for the most part, there will be roles and you will have something that you excel in, but you kind of need to know the landscape. So literally what I would do is, I've already kind of told you in that sense, is I would just focus on building some type of real-time dashboard, or if it's not real time, something that where the data is in a database and you can interact with the database.
Or you have some cron job.
Yeah, something like that. But the thing where it says what RCE is asking, is there a fundamentals of data science SQL world to learn first, is if you are really set on data science and you think like the data analytics thing, and kind of like you're saying, like this kind of SQL analyst side of things, web dev isn't going to be as important. You can get away with you need to then know how to set up a SQL server. That's the first thing I would do. Like, how do you pull down a SQL server and run it from your terminal and then inject a query and inject some data, insert some data, and then pull the data out. You need to know how to do that. That's the first thing I'd figure out how to do. Like, just do that. And then once you know how to put data in a database, you know how to take data out of a database, then I would start doing the data science thing, which is just learn how to classify data. That's the first thing you want to do. And I would make it really simple, two-dimensional data. So like what I mean by this is, when I say two-dimensional data, I mean, data with like literally 2 attributes about it. So let's see if you can classify who's likely to live and who's likely to die on the Titanic. And the only thing you can know is their gender and their age. Now, the answer is going to be, if you're a male and you're older, you're more likely to die than a younger female. That's just, and it kind of makes sense. It's like there's some intuition there. But that intuition will live inside the data, and the way that you classify that using so maybe you build a SQL database, you pull down the classic Titanic data set. If you explore data science, you'll realize there's these data sets. There's the Iris data set, there's the housing data set, there's the Titanic data set. Titanic is a great one to start with because it basically teaches you classification. And what you can do is you can pull that down, throw it into your SQL database, and then you can run some very, very simple classification on it using scikit-learn as a library. And you can do that. If you know nothing about coding, you could probably read enough to within 2 weeks have that project done.
Yeah. So yeah, it's building a SQL server and tables.
Yeah, exactly. The server essentially is just a process that's running. The building the tables, putting data in the table and taking data out of the table and joining tables. That's another way to think about tables real quick, just to help us conceptualize them. Just think of it as a spreadsheet at the end of the day.
Yeah.
It's just a spreadsheet that doesn't have an Excel UI. It's just a spreadsheet that lives hidden in your computer and you can't really visualize it that well. And your only way of interacting it is that query language. And then it returns to you the data points that you've queried from it.
Yeah. Nice. This is the real 10x shit. This is I think, do you mind if I clip some of this and because I want to
do whatever you want, man.
Put some of this into a machine learning intro guide for people, because I think this is super helpful.
Yeah, 100%. Hey, dude, if people are finding this useful, then use it. Absolutely.
Yeah, because because I haven't actually seen anyone break it down like this. Because I don't think there's a lot of people who went down your path, that many that went as far as you down your path.
Yeah,
so I think this is really good.
That's happy to hear, because I do feel like what I saw was in the world that I went through, there was definitely a wave of people who kind of moved around the same time as me. A lot of them, once they got jobs, they literally stopped teaching themselves. I was interacting with someone.
It's most people.
Yeah, it was kind of crazy. It's like, dude, the job. By the way, I just want to say, the job is not the goal. The work is the goal. You want to do 100%, the work. Yeah. So job's just a means to doing the work. And if you find a job that values the work, then you'll get paid well for it. And that's what you want to do. So, and the only way to maintain the work is to continuously learn. So,
Zero to Hero for ML. That might be the title of the video. I'll just do Matthew Finch's Zero to Hero for ML or something. Because this last hour ever we did has been really, really good. That's the thing. The thing you're saying about the work, it's that's just it. I even tweeted about this earlier today, where it was all me and my friends getting good at all these different technologies through the years. You have to understand, when you're going to get a job, you're getting you see it as a checklist. Not everyone, but a lot of people see it as I got to just learn that NumPy. I got to just learn this. It's there's people out there that just learn this stuff because they liked the work and they liked building stuff. And seeing that, that's been my world. And seeing people ask me questions about through all the mentoring and stuff is they're doing the checklist. And I'm it's going to be real tough if you don't like the work, because a lot of that checklist in that job description is just these are natural things that you have to learn to get to the end point you want to get to when you're doing the work. So if you fall in love with the work, that's the thing that gets you 10x. That gets you 50x. We're just escalating.
I like this phrase. This is what I and I use this across the board in my life. This isn't just with coding practices. I mean, I do this with literally everything. It's a really, really simple thing. You don't have to do anything. You get to do all these things in your life.
Yeah.
So when I see a list of things that I have to learn, I'm dude, I get to learn all that shit. Hell yeah, dude. I'm going to go learn that. And then I get to implement it. I get to use it. I get to be one of these people. I used to think about like going back to my life in music. I used to be, when I was younger, before I started. So real quick, back in college. So the funny thing, just so everyone knows, my degree from college is in composition and jazz bass performance. Just so
you're Grammy nominated, right?
Yeah, I am Grammy nominated.
No, he's legit Grammy nominated.
Yeah. This is not a joke. Like I did. Yeah. I know what I'm doing in that world. But I really found, way more interest and love in data science and ML. I mean, I'm a musician for sure. But anyways, what I'm getting at is, in college, before I started throwing shows and started like booking bands and doing all this stuff, I didn't like understand like how bands were performing. I almost thought it was like they woke up and somehow like a venue was like, we know you're really good, come on in here. No, what actually happens is they build that opportunity for themselves. They go through a lot of hard work of emailing people, negotiating things, and then it all leads to what they really wanted to do the whole time, which was they wanted to rock out. If you want to get paid and that's what you want, I don't know if coding is the route. You know what I mean? Like, if your main goal is like, I just want 6 figures, I don't think coding's the route, because you're going to burn out really quick and you're going to feel like you're wasting your time, not going to know what's going on. But if you just want to solve problems and build things like in like kind of an intense way.
Oh,
like,
did the stream get laggy? I think it may have got laggy.
Okay. I might just.
That's right. You can finish.
Yeah. No, but that's like but basically it's like you have to want the end goal of using these principles to solve your problems, because and to be honest, it's a snowball effect. Once you solve one problem with some coding, you're going to realize the potential. Like even just like a simple, like if you can learn how to automate your mouse on your screen, like that's like, I like that. That was a fun project for me early on. Learning how to like move the mouse on the pixels and shit like that. Once you learn how to do that, that's simple enough. That just gives you this sense of like, wait, I can tell this device to do things, and it will do it in a very precise way. Yeah. And there's a beautiful power to that. And if you start realizing the multitude of problems that you can solve, and I'm going to bring it around, then you will realize that you control society at such a scale. You can only do it with technology.
Close the loop. Right when we get to, we're about the 3-hour mark. So that's
this episode,
nice.
We're there.
Nice, awesome. Any like thing you want to push or anything in the end, or anything you want to? I don't know.
I mean, ultimately,
follow you on GitHub.
Don't follow me on GitHub. I mean, you can if you want. It's fine. I have some code up there. You'll probably like it. But at the end of the day, if there's anything I want to push, if there's anything I want to advertise, and this might be cheesy, but like I'm being very serious, is like push yourself. Like fuck whatever anyone else has to say. Like most of the time, honestly, like most people aren't telling you things because they want to help you. Most people don't give you free information. They give you manufactured directions to believe in things. But I promise you right now, I genuinely just want people to succeed. I said it earlier, like empowerment is the real power in life. I've gotten so much further by helping people that honestly, that's the only thing I ever want to advertise to anyone, is that like, go help yourself. Like that is it's gonna be great. And if I can help you, hit me up, and I'll advertise that services. You can find me on LinkedIn. My name is my name. You'll find me.
You want me to? I can post it in the description.
Okay. Post in the description. I will respond to anyone who has questions about this type of stuff. If you ask me things that's not related to this, I may ignore you. I may talk to you. It's really up in the air. But if you have like industry questions, like I want to see people succeed. I want people to do things. So I'll help in any way possible on that front. Yeah,
you guys should definitely take that up. It's very knowledgeable, man. I think we'll do this next week too.
Oh yeah, I think.
Oh, cool. Yeah,
and this is a thing.
Yeah, we'll just do this every Wednesday and come in with questions, and we'll be talking about something crazy, conspiratorial or whatever.
Yeah.
But for now, like, subscribe, donate, do what you got to do, and share to your coder friends. Get 10x.